for those of you who are looking at this question and thinking, oh my God, I have no idea, just hang in there. This is an area that can be memorized and you can learn it. So don't be hard on yourselves. We're going to go through the answer right now. So this is an example of a type 1 error. So when the outcome is determined that there is a difference, there's a difference noticed, but in reality, there was no difference. So that's a type 1 error. And so that means the null hypothesis, you reject the null hypothesis, which is H0, meaning no difference. Okay, so remember that the null hypothesis means there's no difference between the two populations that you're studying. And a type 1 error is rejecting that null hypothesis when it's true and attributing significance when there is no significance. A type 1 error is always referred to as the significance level. And that's what that little symbol means that's right next to type 1 error up there here. A type 2 error, or beta, means accepting the null hypothesis when it is false, and that means not attributing significance when it exists. So we're going to talk about this. There'll be more questions about this as we go along, so hang in there. Alpha and beta here. Okay, how do you reduce the chance of a type 1 error? So what you want to do is keep your significance level small. So the significance level should be very small, which is 0.05, which is usually what our P levels are when we're doing a study. So, or 0.01, that's less frequently used as a significance level. To reduce the chance of a type 2 error is you want to increase your sample size. So that's why bigger studies with larger populations, people feel more confident about. If they're matched well and they're a large population, the sample size, as it gets larger, the data gets closer to a normal distribution, so you can predict, it becomes more reliable in that way. For which of the following procedures is the surveillance period for deep incisional or organ space surgical site infection 90 days? 1, cesarean section. 2, craniotomy. 3, coronary artery bypass graft. 4, laminectomy. And you get to choose 2 of these. A is 1 and 2. B is 2 and 3. C is 3 and 4. And D is 1 and 4. And the answer to this one is B, 2 and 3, a craniotomy and a coronary artery bypass graft. And these are NHSN definitions. So the rationale, surgical surveillance definitions, these are NHSN definitions. There's a chapter in the book and also in the Google Drive. It's the same chapter about surveillance, and you can read about the NHSN definitions there. So surveillance should be conducted for 90 days on craniotomy and coronary artery bypass procedures. In superficial infections, surveillance should continue for 30 days. So a superficial infection would be diagnosed in 30 days, okay? So you're going to continue to do surveillance for 90 days on craniotomy. An appropriate indicator to monitor process compliance would be A, class 1 surgical site infection rate, B, appropriate antibiotic dosage, C, central line associated bloodstream infections, and D, infections caused by multi-drug resistant organisms. Okay, the answer to this one is B, appropriate antibiotic dosage. Okay, how do these measures differ? So what's a process measure? What's an outcome measure? So process measures would be, examples of process measures would be hand hygiene, that's a process. MRSA colonization is actually an outcome, so that would be an outcome measure. Falls are also an outcome measure. Communicable disease reporting would be a process where the diseases themselves would be an outcome. Instrument reprocessing is a process. Obviously, it has the word processing in it. And needle sticks are outcomes. So what key infection control activity is defined as the systematic ongoing collection, management, analysis, and interpretation of data, followed by the dissemination of these data to public health programs to stimulate public health action? A, research, B, surveillance, C, benchmarking, and D, accreditation. Okay, this one is surveillance, B, surveillance. Number 6, an IP is reading a journal article that states that the data the authors collected are normally distributed. What does this mean? A, when the data are plotted on a curve, it is skewed. B, the mean is less than the median. C, the skewness value is equal to 1. And D, the mean, median, and mode of the data are equal. Okay, the answer to this is D, the mean, median, mode of the data are equal. This picture is in your book, your study guide. So this is what a normal distribution looks like. This is also known as a bell curve. So only 3 points in 1,000 will fall outside plus or minus 3 standard deviations. So when we talk about standard deviations, and we'll talk a lot about this as we go along, this is the mean. This little mu sign here is the mean, median, and mode. It will always be right in the middle of the 3 of them. If it's a normally distributed data set, they should be right on the same. They should be the same. 1 standard deviation goes from minus 16 to plus 16 here. And so that means 68.26% of the data is going to fall within 1 standard deviation of the mean. 2 standard deviations are out here from minus 26 to 26, okay, these lines here, and that means 95.46% of the data in a normally distributed population of data points is going to be right in 2 standard deviations of the mean, okay, and that's here and here. And then 3 standard deviations of the mean, you're going to have 99.73% of the data fall right between 3 standard deviations of the mean. And these are our outliers here. Okay, so we're not going to see as many data points here, and you can look at these columns and study them. So the important thing to know is that in a generally just a normal distribution or a bell curve, the mean, median, and mode are equal, and that the data, these percentages are important. Which of the following is indicative of a superficial surgical site infection? A, pain at the incision site 10 days after a breast reduction procedure. Drainage is culture positive for methicillin susceptible Staphylococcus aureus. B, stitch abscess that is cultured 14 days after surgery and is positive for Enterococcus faecalis. C, purulent drainage from an episiotomy that occurs within 5 days of delivery. And D, burn wound that cultures positive for Acinetobacter baumannii 10 days after debridement procedure. Okay, so the answer to this is A, pain at the incision site 10 days after a breast reduction procedure. The drainage is culture positive for methicillin susceptible Staph aureus. So what is an SSI that is superficial? So it occurs within 30 days of the procedure. Only skin or subcutaneous tissue is involved, plus one of the following. So purulent drainage with or without laboratory confirmation. Organism isolated aseptic from an aseptically obtained culture of fluid or tissue from the incision, or the incisions deliberately opened by a surgeon or a physician at the bedside. And then one of the following symptoms. So you have to have symptoms, physical symptoms, include pain, tenderness, swelling, redness, heat. Culture negative finding does not meet this criterion, so a physician can also diagnose an infection. So you can have that expert opinion also there. So let's go back to that. It has within 30 days, the procedure, breast reduction procedure, the drainage is culture positive for the organism. The stitch abscess isn't part of the procedure, which, they don't say what the procedure was. They say it's a stitch abscess, and you have a positive culture, but because they don't say what the procedure was and it's just part of the stitch, it's not superficial surgical site infection. This says that there's purulent drainage from an episiotomy that occurs 5 days from surgery, and it doesn't have any of those other findings like the physician diagnosis, pain, heat. It doesn't say anything about culture results either. And then the burn wound that culture's positive for Acineta Bomani 10 days after a debridement procedure. Let's look at that.